Hey everyone, and welcome to today's Explainer. I am super eager to have you join me today because we are going to unpack a massive global and local paradox, one that affects, quite literally, every single one of us. We're looking at a resource that is supposedly everywhere, yet somehow it's incredibly hard to secure.
All right, let's kick things off with a staggering fact. 75% of our planet's surface is covered in water, and it's a constantly renewable resource, too. It's continuously refreshed and moved all around the globe by the hydrological cycle, surface runoff, groundwater recharge. This stuff happens naturally, day in and day out. With 75% of the globe covered, you'd think we have absolutely nothing to worry about, right? Well, actually, contrast all that blue with this really staggering reality. Despite living on a blue planet, projections show that 2 billion people will face absolute water scarcity by the year 2025. 2025 is right around the corner. So how in the world do we go from a planet covered in water to billions of people without enough of it? So we clearly have a massive global crisis on our hands. Here's exactly how we're going to navigate through this explainer today to understand both the problem and, hopefully, some brilliant solutions. We'll cover 1. The paradox of scarcity, 2. What drives water depletion, 3. The mega dam dilemma, and finally, 4. Rainwater harvesting solutions.
Let's jump right into part 1. The paradox of scarcity. Water everywhere. Let's see why global abundance doesn't mean local access. When we hear the term water scarcity, we instantly picture barren, cracked earth and severe droughts. But honestly, scarcity isn't just a lack of rain. A lot of the time, the reality actually looks like overexploitation, excessive use, and unequal access to the resources we already have. It's essentially a profound failure in how we manage, share, and use our available freshwater. Which brings us to Section 2, what drives water depletion? Let's take a look at the human impact that creates this perfect storm. If we break down the core drivers of this scarcity, we're basically looking at 4 massive pillars. First up, population growth. More people simply means we demand more water for domestic use, plus we need more water to grow extra food. Second, and this is a huge one, agriculture. Irrigated agriculture is actually the largest consumer of water. We're seeing farmers relying super heavily on tube wells, which completely drains groundwater levels and, ironically, threatens our future food security. Third is industrialization and urbanization. Dense cities and multinational corporations put immense pressure on freshwater for manufacturing and for hydroelectric power. And finally, the fourth pillar, water pollution. Even if an area has abundant water, it becomes completely useless to us if it's heavily polluted by domestic waste, industrial chemicals, or fertilizers. Now, governments are obviously scrambling to fix this. Take a look at the Jal Jeevan mission, for example. It's a massive initiative designed to provide piped potable water to every single rural household. The target metric here is 55 liters per person per day. It's a seriously ambitious logistical feat. And alongside this, you have initiatives like the Atal Bhujal Yojana tackling the demand side. They're focusing heavily on changing community behavior from, mindless consumption over to active conservation in water-stressed regions. Okay, moving on to Section 3, and this is really interesting, the mega dam dilemma. Let's look at engineering the flow. So India actually has incredibly deep ancient hydraulic roots. We're talking sophisticated structures dating way back to places like Sringavarapura. But jump to the modern era, and mega dams like Bakranangal and Hirakud, well, they were famously hailed by India's first Prime Minister, Jawaharlal Nehru, as the temples of modern India. They were seen as the absolute pinnacle of progress and our mastery over nature. But as you might guess, engineering the flow of nature comes with some serious trade-offs. Let's look at the pros first. These multi-purpose projects are absolute workhorses. They provide vital irrigation, they generate immense electricity, supply drinking water, help with flood control, and even aid in navigation. However, the cons are significant. The ecological and social drawbacks are severe. Dams disrupt the natural river flow, which leads to excessive reservoir sedimentation. That destroys aquatic habitats. Plus, they displace massive local communities. And get this, ironically, this sedimentation caused by dams has sometimes triggered the exact floods they were built to prevent, all while depriving downstream areas of natural, fertile silt. And if that wasn't tricky enough, add politics and geography into the mix. Water diversion creates intense, really complex friction between states. For example, the Krishna Godavari dispute flared up over Maharashtra's Koyna project because it affected the downstream water flow into Karnataka and Andhra Pradesh. Similarly, you have the Sardar Sarovar project on the Narmada River. Because it spans 4 states, it's been a huge source of controversy over exactly how those water resources are shared and managed.
So, to ease some of the massive pressure on our river systems, especially from agricultural overuse, there are programs like the Pradhan Mantri Krishi Sinchai Yojana. This operates on two main principles: har ke ko pani, meaning water to every farm, and per drop more crop. The whole goal here is just maximizing the efficiency of every single drop of water used in farming, so we can finally move away from wasteful flood irrigation. Let's pivot to our fourth and final section: rainwater harvesting solutions. Because of all the tension around megadams, we're returning to our roots.
Honestly, looking at these traditional community-led methods is mind-blowing. It is pure, localized genius. In the mountainous western Himalayas, you have gulls or kols, seamlessly diverting water for agriculture. Down in the Bengal floodplains, they use inundation channels. In arid places like Rajasthan, they build khadans and jahads, which are these ingenious rain-fed storage structures. And my absolute favorite, in Meghalaya, they utilize a bamboo drip irrigation system that uses gravity to deliver exactly 20 to 80 drops of water per minute right to the plant roots. It's literally 200-year-old precision agriculture. Let's zoom in on one of these methods, the Rajasthani rooftop tonkas. The mechanics are just brilliant in their simplicity. First, they let the initial spell of rain wash the sloping roof completely clean. Then the subsequent pure rain showers flow down perfectly placed pipes. Finally, this incredibly pure water, known locally as Pilar Pani, is stored in massive underground room-sized tanks where it stays cool and safe until the scorching summer months. And while modern canals have reduced the strict necessity of these tonkas, a lot of locals actually still prefer them, simply because this natural rainwater is way purer than tap water. And hey, this isn't just ancient history. It's a critical part of modern survival. States are actually taking these traditional concepts and scaling them through law. Tamil Nadu stands out as the very first state in India to make rooftop rainwater harvesting legally compulsory for all houses. They even back it up with legal punishments for defaulters. They are not messing around.
To put the potential of this into perspective, 100,000 liters. That is the amount of water collected annually by Gendathur village in Mysuru. Nearly 200 households installed these rooftop systems, and they hit an 80% collection efficiency. It just goes to show what a committed community can achieve when they take water security into their own hands.
And you know what's really wild? Even in places you wouldn't expect, these systems are a total lifeline. Look at Shillong in Meghalaya. It's located right near one of the wettest places on Earth, yet Shillong faces acute water shortages. Because of that, nearly every household relies on rooftop harvesting for up to 25% of their total water needs. It proves that abundant rainfall absolutely does not equal water security unless you actively capture and manage it.
So, we've covered a ton of ground today. We've seen the sheer scale of the paradox, the drivers of depletion, the controversies of mega engineering, and the elegance of traditional local solutions. So, I want to leave you with this provocative thought. If 2 billion people are set to face absolute water scarcity by 2025, what is your personal water conservation proposal? Take a look at your own water footprint. How can you apply these centuries-old lessons of conservation in your daily life to help secure our collective future? Thank you so much for joining me on this explainer today. Keep learning, keep questioning, and I'll catch you next time.